regarding the programming mini sessions, I just recorded the first one, and I will, catch up, because last week I need to post 2 mini sessions. I call it mini sessions, so each one between 10 and 15 minutes. So this week we will have 2. Last week 2. So these 2 weeks are 4 mini sessions. So I will do one by one. After I complete one, so I will send you announcement so you can, watch it. Although it's pretty short, but when we build up, every class we add something, 10 something minutes. So gradually, so we can get ourselves ready for the programming. Okay. All right. Today, topic part B of module 3, understand SQL data. Last time we understand SQL structure. So this time we will understand the SQL data. All right. B.1, numeric and string data. The most commonly used data in our SQL queries or database, programming. All right, yeah. Here, first, let's look at the numeric data type. Yeah. All right. Integer numbers of various sizes. Yeah. Here you can see, we have different ways, but most frequently used int, integer. And after, because when you declare some integer data type, you need to specify the data size. So so after int, we can add a pair of parentheses, the number of digits for the integer we can put there. Yeah, pretty simple. Yeah. All right. Small int, integer, the full name. Yeah. But most frequently used way, int. Okay. All right. So here you can see just 2 digits, right? int parenthesis 2-digit integer for this, line field example. Okay, yeah. And another thing you may notice, this int here, we use lowercase. Look at here, lowercase. Although you can, here you see the capital, right? Capital case, name here, but in, most of the time, when we write our specific SQL statements in this location, people use lowercase. Yeah. Remember last time we learned regarding the keywords, SQL keywords, right? This int keyword. Yeah, no problem. But in this place, most of the time, people use lowercase for the data type. Here you see default, but here, lowercase also quite often. Yeah, here. So here you see uppercase, lowercase. Yeah. Usually, so people, when we write the statement, the main part of the statement, we use the uppercase. But, inside the parentheses, yeah, so here, let's say, so, inside the parentheses, when we describe the fields, most of the time we use lower case. Yeah, like, this place, this place. Okay, We know first, not case sensitive. Second, the way that most people like to do. No. Yeah. All right. Another type of numeric data. Oh, sorry. Yeah, here. You know why? Yeah. I need to cross out this. You know why? Yeah, because when I edit my PowerPoint slides, I copy from my older version, but the font size is different. Yeah. But if I replace the whole thing, I just copy the font size. But if I leave the first number of the previous size, then I do not need to change the size. But I need to remove the first word. But sometimes I forgot, remove. So you see something strange. Yeah. Here, this is that problem. Yeah. All right. Floating point, real numbers of various precision. Yeah. Float or real, that's single precision. Okay. Then double precision. Yeah. All right. Yeah. All right. But float, we use quite often. Float, also lowercase. All right. Parenthesis. Yeah, you will see similar to this way, I, J, okay, similar to that way. Okay. Then formatted numbers can be declared by using decimal. Okay, IJ, yeah, because you need to describe precision. Okay, yeah. So what's the meaning? Precision I, the total number of decimal digits. Because you have decimal point. The number of digits before the decimal point and the number of digits after decimal point. You need to add them up. Okay, that's the total precision, the precision number. All right. Scale, yes, but we need to specify the number of digits after the decimal point. Yeah. So then you can understand. Yeah, the details of your data type with these two numbers. All right, yeah. And here, one thing in computer, because here there is something we know when we represent non-integer numbers, float or double precision, inside computer, we cannot represent floating point double accurately because in our computer, we can only finite number of digits after the decimal, right? Finite number of digits. Yeah. So at some point, we have to approximate. We have to do the truncation. We have to truncate. Okay? So keep this in your mind. So many times we need to do approximation when we deal with numbers, not integer numbers. Integer numbers we can represent precisely. Okay, so that's perfect thing we like to have. But we need to represent non-integer numbers. So then there is a approximation question. Okay, approximations. Okay, yeah, and by truncation, right? For example, 1/3 you cannot represent precisely, right? Yeah, so 0.333 at some point you have to do the truncation. Okay, all right, yeah. But in our computer, remember, computer we use binary system, right? In our computer, internal representation. What I mean, computer machine. Internal, all right. Look, Frederick, all right. I will add him back. internal representation. It's a binary representation. That means after the decimal point, you need to use the binary representation after the decimal point. Okay? Yeah. Then think about the truncation issue. Yeah. All right. 0.5, because that's equal to 1/2. The denominator is power of 2. Then you can use your binary representation to represent this precisely, right? 0.1/2. Okay, 1/2 decimal point 0.1 after the decimal point. Okay, yeah. Similarly, 0.25, 1/4. Right? You can represent it precisely, right? See, yeah. So after decimal point, like that. Here, that's the binary representation, binary. Okay, but one decimal representation we are familiar with, we know, look at this 0.6. This is a decimal representation, right? Decimal representation, we can represent 3/5, right? Okay, but when you represent binary expressions, can you use finitely many bits after the decimal point? You cannot. 0.6, you have to do approximation. You have to do approximation. You cannot represent it using the binary expression precisely. When you do approximation, you need to do truncation, right? When you do truncation, you lose precision, right? Yeah. All right. Think about in the banking system. You do the truncation in each amount of money, you may not take away too much, but when you process large amount of money, the truncated part, add it up, think about it. Okay, yeah, that's quite a lot. Okay, yeah. So for that kind of reason, you need, in your mind, you need to be aware of this kind of approximation. When you use SQL, when you use relational database, SQL data, that approximation, that truncation, sometimes it could cause some relatively big difference. Okay, yeah, all right. Character string data type, another important type of data. Yeah. The most frequently used two data types, numeric and character string. Yeah. String, yeah, character, okay, yeah. Fixed length, yeah. Capital CHAR, parenthesis N, you need to specify the number of characters fixed. Yeah. So this number of characters fixed. Yeah. All right. Varying length, yeah. VAR, CHAR, parenthesis N, and you have a few other expressions, but we use these two versions most frequently. Okay, yeah. Here, although you see capital way to write these two data types, but when we define our tables, usually we use lowercase. Yeah. Similar to our INT way. Yeah. This place, people use lowercase. Yeah. So that default here, although you see capital, but you know, lowercase also quite common. Okay, yeah, because people may ask, why you use lowercase here but capital case there, right? You know, yeah. So it's hard to answer that question. Okay, yes, all right. So here you can see variable, character, varchar, up to 3,000 characters. When you have more than that number of characters, truncation, you may lose your data. Okay, be aware of that. You may lose your data by truncation. Okay, yeah. So when you define, yeah, because when you define each table, you need to be aware based on your business application, how many characters you need to put there. Okay, yeah, put appropriate number there to avoid truncation. Okay, to avoid truncation. Yeah, all right. Otherwise, you lose your data. Okay, yeah, yeah. But here, another thing. Yeah. So here, variable characters, yeah, and the fixed length characters. What's the difference? Yeah, yeah. You may ask me when we compare, what is the difference? Yeah, yeah. I will do comparison after I give you another property. After I talk about one property for the fixed length string size, then we can discuss this question. Yeah. All right. B.2, understand null value. Okay. Yeah. All right. What is the null value? This value is very special, quite different from our regular values. 1, 2, 3, normal, regular values. Now, you cannot treat it as a regular value. The first thing, in your business, we need it. We need the special value from our business needs. In our business, we have special situations. We need to represent null value. Okay, yeah, let me describe our typical business situation related to the null value. Null is used to represent a missing value. Definitely you do not know it's a value. Otherwise, you will put that value there, right? So it is a missing value. But for what reason it is missing? There are several reasons it could be missing. Yeah. But that it usually has one of the 3 different interpretations. Could be more, but these 3 most commonly used cases. Yeah. The first one, unknown value, exists but not known. In our business, we need to collect data, right? Yeah. So in our business, we deal with our customers. So we need to collect data from customers. But many times, we may not get some specific information from our customer, right? What you should do, okay? You have different ways you can deal with in this situation, but here, this is a special way. We just put null there, okay? Null value, because null value will convey some special meaning. So we will discuss, okay, null value. Yeah. Unavailable or withheld value. Yeah. Exists, but is purposely withheld. Yeah. Another situation. We know it exists. Yeah. But we just, well, due to various reasons, we just do not want to put there. Okay, yeah, withheld, yeah, just something, some special reason. No, yeah, all right. And another one, not applicable attribute. Yeah, it does not make sense. Here, Yeah, it happens, right? Yeah. So the attribute is undefined for this tuple. Yeah. We have business needs like this, right? Yeah, yeah. I think you have the example from your daily life. Yeah. I encounter such things, you know, myself. Not applicable. Okay. Yeah. All right. Why use null instead of some special value? Yeah. People may argue, if I do not know some person's information, may I put an empty string? Yeah. Empty string, blank character, things like that. Yeah. You can, but you need to think about some possible consequence. Okay. Yeah. Although you can do it. Yeah. Although you can do it. Yeah. Yeah. I did this kind of thing before myself. All right. Yeah. But you may have some situation. You may get some problem. Here, let me describe that. Yeah. Because when you do that, that's the normal value, right? That's the normal value. Okay. If it is a normal value, it is buried in the large amount of data you may not be aware of, right? Now here, one purpose to use the null value, because it's so different from the null values, it will cause different behavior in your SQL query. So it would make you aware of it. When you do the query, the behavior of this piece of data is quite different from the normal data values. So just, it's like send you a warning. When you see the null value, you get a warning. You need to fix the problem. If the data is missing, remember the data missing case. If the data is missing, just give you alert. You need to collect that data. You need to frequently talk to that customer to collect that missing data piece. It has this usage. But if you put normal value there, no warning, everything is normal, you won't get alert. You may not be aware of, you need to reach out to get that data, to fix the problem, to avoid future bigger other problems. Yeah. So that's importance of the special value. Okay. Yeah. The DBMS treats it differently from other values. Yeah. How different? We will see. You know, the behavior, you know, in many different ways, we will get rows involving null value quite different. Yeah. Okay. All right. Handling null values in DBMS. Okay. Yeah. Who determines the meaning of null? We have some possible different meanings, but who is responsible for interpretation of those values? Right? Can DBMS do it? No. How can DBMS do it? Right? Because DBMS is not responsible for your business details, right? We know DBMS is a general software, application software, right? Yeah. Yeah. So not SQL is not responsible. Okay. Yeah. SQL does not distinguish among the different meanings of null. It is a business decision. Yeah. you need to be familiar with your business. Then you can do the correct interpretation. Okay, yeah, so now DBMS, now SQL, people who are familiar with the business rules, those people, they can interpret in the right way. Okay, yeah, all right. Different individual null values than the first typical behavior for null values. How do we treat two null values? You may have two null values, right? Yeah. Two rows, okay? For a specific field, let's consider two rows. They both take null value. What should we treat in that situation? It's not normal value, we know. Yeah. So here, the rule is like this. Each individual null value is considered to be different from every other null value by DBMS. That's the special rule for this null value. You see the spelling the same, NULL, two places, but DBMS treat them as two different values. Why? The reason is simple. Because when we fix these two pieces of data later, you need to collect. You need to, reach out, collect. After you fix those two pieces of data, it's very likely they could have different values, right? Although it's also possible they could have the same value. But we need to consider the case they could be different. That's more important, right? So for that reason, DBMS treat them as two different values. It will cause different behavior later when you do the query. Two values we treat different. Okay, all right. So for example, you may argue, what kind of difference, right? What kind of difference? For example, okay. So here I give you an example, okay. For example, one person's name, Smith. And another name we do not know, so it's null. Okay, yeah. So that's one row. All right. Another row, also Smith. But the other one also null, right? Yeah. These two, from the spelling, visually, they are completely the same. But DBMS treat them different. Because when you fix the first null, later second null, it's highly likely they could be different. Highly likely. Okay? So you need to consider that special case more for the behavior. Okay? This is just one example. Later we have many such examples. All right. The comparison logic is different. Comparison logic. When you compare these two values, A value and a B value, when you compare, if A takes null, B also takes null, the result is false. Null compared with null, they are not the same. So the Boolean value, false, not true. Or probably later we will see. Yeah. Other than null and false, other than true and false, there is another special Boolean value in SQL, unknown. We will get there. Unknown. Unknown. Okay? Not true, not false. It is unknown. We will get there, all right? Yeah. When we compare null values, okay, yeah, all right. Is null instead of equal null. So here, when you compare, if a value is null or not, you should use the is operator, okay? Is operator. It's an operator is null. Yeah. You cannot use equal because is null, you just, the DBMS detects if this value is null or not. Okay. Yeah. So then it will tell you if it is null value. But if you use equals comparison, DBMS treat as a different value. It does not tell you if it's null or not, but it just tells you this value is different from that null, that specific null different. Okay, yeah. So be aware of this special situation. Okay, yeah. So quite special regarding null value. A lot of normal ways you need to change. All right. Yeah. A special comparison operator is used here. Is operator. Okay. Yeah. All right. Yeah. B.3, other data types. Yeah. Other than numeric, string, we may have other data types. Boolean data. Oh yeah. Yeah. So, B.3, right? Yeah. Okay. Yeah. First, Boolean data type. Yeah. Other than those two types, Boolean, we need to use. Okay. All right. Here, it's a 3-value logic, not 2-value logic. Yeah. In our programming language, based on our experience, we are familiar with 2-value logic, Boolean, true and false. No third value. But here, in SQL, specifically in SQL, we need to change our mind to 3-valued logic. True, false, unknown. Why you need to add unknown third possible Boolean value due to null value? When null value is involved, can you say true? Not 100%, right? Because when we say true, we must make sure it is 100% true. When we say it is false, we must make sure it is 100% false. But if it's not 100% true, it is not 100% false. The only way we can take unknown. Right. That's what we have in the SQL. Because of the presence of null values, so that's data type. Later we would discuss this Boolean operations with unknown value involved. You need to do Boolean operations, right? Yeah. And or not, right? Yeah. Boolean operations. But think about with unknown involved. How do you determine the Boolean value expression? Values for your Boolean expressions. Okay, yeah, later we have more discussion on that. Yeah. Date data type, date. Yeah. Another commonly used data type, date. We need to represent date in SQL. Yeah. The format, standard SQL format. 4-digit Y part, dash, 2-digit month part, dash, 2-digit day part. That's the standard SQL format. SQL format. You can see it's quite different from our everyday date format. The reason is simple. In different countries, people use different ways to represent date, right? Yeah. But in the world, because SQL is used in the whole world, you have to use one single standard format for all people in the world. Okay. Yeah. Then this format is adopted. Okay. Yeah. 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 All right. Yeah. All right. Time data type represent time. Yeah. That's, you know, yeah, most people, yeah, I think most people use this way, right? Yeah. 2-digit hour part, colon, minute part, 2-digit, colon, second part, also 2-digit. Okay, yeah, yeah. All right. But sometimes we need to combine date and the time together. Yeah. So it's called a daytime format. Together, daytime format. Yeah. Then you just use a space to separate. Yeah. The first part, date format, space, time format. Okay, yeah. So be aware of, especially the date data type. If you use a different way, SQL would reject it. Okay, your DBMS would reject it. Okay, so your date format is wrong, but yeah, some case it won't reject, yeah, because for example, if you use, yeah, let's say 2023, yeah, the month here February, right? 2-digit, you just use 2. You use 1 digit, not 2-digit, not 02. You use 2, not 02. Okay, yeah. So then 20, yeah, then it won't be rejected. Okay, yeah, this is okay. Won't be rejected because only slightly different from the standard format. Then SQL will insert 0 in front of that 2 automatically. Okay, when you see your data, you will see 02. Okay, yeah. So that situation should be fine. Yeah. Similarly, you know, dash suppose 5, you know, it won't be treated as a violation. Okay, yeah. For that kind of little thing, you know, reasonable small difference, yeah, SQL has the tolerance, you know, to make it the right format automatically. Okay, yeah. So don't worry about that situation. All right, so next. B.4, compare values. Yeah. Now, let's compare values, the general case. Compare values. Yeah. First one, comparison operator equal. When we compare, if 2 values are equal or not, we use this comparison operator. Yeah. Here, remember, we are in SQL. SQL has its own way, and it is quite different from other programming languages. In our programming language, when we compare, we use double equal, right? Think about, in our typical programming language, we use double equal, right? Yeah. If single equal, we treat it as assignment. It's an assignment, it's not a comparison. That only double equal, we treat it as comparison, okay? But when you go back to SQL, single comparison, a single equal for comparison, all right? Yeah. Be aware of that, yeah, because people may have the habit, you know, automatically put the double equal, syntax error. They will put double equal there, that's the syntax error, okay? Yeah. For exact match. Yeah. Yeah. All right. no, yeah, when we use this operator, no order for the comparison field is required. Order field, yeah. Larger, smaller, the value is larger or smaller. You don't need that information because you only want to do the exact match. Which one is larger, which one is smaller? It's not important. Exact match. Okay, yeah. All right. Without order definition for the field, it still works. Here, why I emphasize the order information? Because later, when you use the less than sign, greater than sign, you need to use this order information. Otherwise, you cannot do comparison. But equal comparison, equal sign, you do not need the order information. In other words, even the order is not defined for the field, you can still do equal type comparison. Okay, yeah, all right. Less than and greater than comparison. But this time, get the order information between two values. The order definition is required. Otherwise, you cannot do comparison. Yeah, but here you may wonder, why you mentioned that order information. Because it looks like you always have the order defined, right? Yeah, later I will talk about the order definition a little bit. Yeah, so here you only need to know we need to have the order definition before you can use less than and greater than comparison. Yeah, and order must be defined. Yeah, because you may consider situation there is a possibility. Yeah, so here, possibility that the order is not defined. For a field. Okay. Here you may wonder, how can it be possible, right? Because based on our real life experience, we know the order is always available, right? When we compare strings, numerical values, even other values, order always important, available according to our personal experience. All right. But you may have the situation, it's hard to define an order for the field. Yeah. Think about, how about the binary data? In SQL, we can store binary data in the table. Remember? Yep, SQL. It is allowed to store binary data in table. Although we may feel it's not convenient to store binary data, but SQL supports binary data storage. There is some possibility situations that people may need to store the binary data, okay? But think about when you store binary data, how do you define order for that field? Okay, it's impossible to define. There is no good way, convenient way to define an order, right? Yeah. In that situation, think about you apply less than, greater than. It does not make sense. Okay, yeah. But you can use equal sign, right? Because the order definition is not needed. You just compare exact match. Although the binary data, you can still compare exact match, right? You compare the binary bits, bit by bit. they're exactly the same. Okay, yeah, think about that meaning. Okay, yeah, all right. Compare values for individual data types, numeric data types. Use the natural value order. So we don't need to define it. So we know numerical order. Yeah. So that's the simple case. But for string data type, character dash string data type, we have a natural order, right? Yeah. The alphabetic order. Alphabetic order, we can do comparison. Yeah. Or sometimes people call dictionary order. Yeah. Same thing. Dictionary order. Okay. Yeah. When you look up in a dictionary, you use the alphabetic order. Okay. Yeah. Yeah. It's quite different from the numeric order. Yeah. So later we will compare a little bit. Yeah. When a string value happens to be a number, sometimes, although it's a string value, but if you look at the character by character, it's a number. Yeah. Do not get confused with these two orders. Here, let me give you a simple example. Okay? Yeah. So here, string, I need to put a pair of quotes. 1, 2, 3, quote. That's string. Okay? All right. Then another string, 2, 3, quote. Single quote. Here I use single quote. When we do comparison, we have two ways, regarding the numerical value, we have two different ways to do the comparison. Okay. First, let's use the alphabetic order. Alphabetic order, you compare the highest character first, right? Dictionary, from the leftmost character, you do comparison. 2 is clearly larger than 1, so your result will be 2, 3 is greater than 1, 2, 3. Okay, all right. Next, numerical order. All right. This time we remove the pair of codes. 2, 3, 2-digit. 1, 2, 3, 3-digit. So the numerical value 223 less than 123. See the difference? That's the meaning. Do not get confused. Okay, the string value, numerical value comparisons. Yeah. Yeah. Although it's simple, yeah. But when I give you these questions, in my previous classes, many students couldn't tell which one is larger. Okay, for string comparisons, typically I ask you to give me the order in the string comparison. Okay, yeah, use in the alphabetic order. Okay, yeah, all right. Date and the time data type. You also need to do comparison, date and the time data type. Okay, yeah, all right. For a less than comparison, an earlier date is considered to be smaller than a later date. And similarly with time. Yeah. That's the order definition for date. 1990 something is less than 20 something, that kind of comparison. Yeah. 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 This part, it's very easy to understand. Yeah. People will get used to it easily. Yeah. But alphabetic order, regarding the numerical values, sometimes people get confused. Yeah. People tend to use their natural numeric order to do the comparison. Okay, yeah, all right. Properties for values and a character string data types. Now let's look at the properties. First, for a string value, a literal string value, when we enter SQL data, we need to enter strings, and we treat as the literal value, fixed literal value, not variable, okay, fixed literal value. Then it's case sensitive. So here it's data. Yeah, because case sensitive, because this situation, it's data, not keywords. We know SQL keywords, case insensitive, right? Do not get confused with that. SQL keywords. But here, the data part, case sensitive. Okay, yeah, all right. Placed between single quotation marks, apostrophes. Yeah, so I use that single quote. Yeah, that's, so here, this is the SQL standard. So I mentioned SQL standard. Yeah, but double quotes are also supported by MySQL. Okay, so if you enclose literal string values within a pair of double quotes in your SQL script, also works. Yeah. So MySQL supports that. Okay, but it's not a SQL standard. Okay, so that's the difference. For fixed length strings, remember that CHAR data type, parenthesis n type. Okay, yeah. Because although some field declare certain number of characters, but many times you may not have that many characters, right? Yeah. Then padded with blank characters to the right for shorter strings. If you have shorter than that required number of characters, padded by blank characters, yeah, to make that fixed length long. Okay, yeah. But why to the right, not left? Yeah, so, yeah. Why? Yeah, because remember we use the alphabetic order. When we use alphabetic order, we start our comparison from the leftmost character, right? So if you pair at the left side, you change the order, right? You change the comparison order. But if you pair to the right side, you do not change the comparison order, right? So that makes more sense. Yeah, all right. For comparison purpose, strings are considered ordered in alphabetic order. So you know that. There is also a concatenation operator. You join two string values. By concatenation, use this double vertical bar. In Java, use plus sign, right? Yeah, so here we have the cases. In Java, so here, concatenation. Yeah, concatenation. Yeah. Yeah, let's look at a few examples. Java, we use plus sign for string concatenation. In PHP, we also need to do concatenation, yeah, but we use dot, yeah, dot for concatenation, okay? Yeah. In SQL, for concatenation, we use double vertical bar, you see? Yeah. In different programming languages, we use different ways for concatenation, okay? Yeah, all right, yeah. So then, now another thing I like to, before we end today, just 2 minutes, another probably I like to compare with fixed characters data type and a variable string. Yeah. We specify in parentheses the size, yeah, or the maximum size, and for fixed character string, fixed string length case, you need to pad with blank characters, but for variable, you do not pad, okay? Yeah, because if you do not have that many characters, you just use the shorter strings. Why you need to pad, right? So for this reason, you can see the comparison, the clear difference of these two data types. When you use fixed string length, you do not save any space. When you do not use that much of the length, you take that amount of space. But for variable string size, if you do not use that many characters, you can save space, okay? You can save space. So that's the another reason this variable length string data type is used more often. Yeah, because you want the flexibility and you want to save space. Yeah. Think about when you declare 3,000 characters, the largest size for this field, 3,000 characters, but you only use 3 characters. You do not have that many characters. You only use 3 characters. Do you need to pad 2,997 blank characters? That's not a good way, right? That way, not smart, right? Simply not smart. Yeah. All right. Yeah. So let me stop here so we complete this SQL data basic property, this part B. Okay.